fractions in one variable. How do we solve linear equations? Well, to solve an equation means to find the value of the x that would make this a true statement. That is, the value of the x that would make both sides equal. So, in order to solve for this equation, we want the constant number. This is a constant, and this is a constant. We want those two to be on the same side, and the variable terms, that is the 3x and the 7x, on the opposite side. So here's our given equation. What we're going to do first is we're going to move this over to the other side. And because it's a minus 4 here, I have to add 4. I have to do the opposite or the inverse of this. Inverse of subtraction is addition, so I have to add 4 and add 4 to both ends. This negative 4 and this positive 4 cancel out, so you have a 7x on this end. 8 plus 4 is 12, so you get 7x equals 3x plus 12. Now we want the variables to be on the opposite side, so to move that over to the other side, I have to subtract that whole term. So minus 3x minus 3x, we get 4x equals 12. That's because the 3x and the negative 3x cancel. And then we divide by 4, or you can multiply by the reciprocal of 4. Remember, 4 could be written as 4 over 1. Reciprocal of 4 over 1 is 1 over 4. So you can multiply by 1/4, multiply by 1/4, which is the same thing as just divided by 4 and divided by 4. So that would give you x equals 2. Sorry, x equals 3. That is, if I were to take this value, plug it in here, and here, it would make both sides equal. And let's check here. If I plug in 3 here, 7 times 3 is 21. 21 minus 4 is 17. So it makes this side 17. Let's plug it in here. 3 times 3 is 9, and 9 plus 8 is 17 as well. So 17 equals 17, that's true. So the final solution for this example would be x equals 3. Let's look at example 2, which involves fraction. A lot of students don't like fractions and decimals. The best way to approach or to solve this problem would be to get rid of the fractions first. And how do we get rid of the fractions? Well, you can multiply both sides by the LCD, the least common divisor, or the LCM of 2 and 3, right? That is, the numbers 2 and 3, they both go into the number 6. They also go into 12, right? And so on. But we want the least common multiple of 2 and 3. So 6 would be the least. So let's go ahead and multiply everything by 6. If I multiply this side by 6 and multiply this side by 6, 6 times half, and then 6 times negative 4 is what we get, which equals, of course, 6 times this other side. Well, what is 6 times half? Well, 6 times half basically means half of 6, which is 3. So that's going to turn into 3x plus 5. And then this is going to be 24. 6 times a third means a third of 6. So that simplifies into that. Now, the next step would be to distribute the 3. So 3 times x and 3 times 5. 2 times 2x, and 2 times negative 1. If we do that, we get this. Right? So the steps we've done so far is we multiplied everything by the LCD, distributed the 3 to get this. The next step would be to combine the like terms. Well, like terms in this case, we have 15 and 24. Those two don't have the variable, so they are like terms. 15 minus 24, well, that is equal to 9. So you get 3x minus 9 equals this side. Now the next step would be to move the variables to the same side and the constant numbers over to the other side. Well, how do we do that? Well, we can add 9 because you're subtracting here. To undo that, you have to do the inverse of subtraction, which is addition. So if you add 9 here, you have to also add 9 here to balance the equation. So you get 3x equals 4x, and then if you combine those two, you get a 7. Next step would be to move that 4x over to the other side. And of course, if I have to take this term over to the other side, I have to subtract it. So if I minus 4x, 3x minus 4x simplifies into negative x. And then over here, you're just left with 7 because the 4x and then negative 4x just cancel out. Now, negative x means it's a negative 1 times x. Inverse of multiplication is division, so that means we can divide both sides by a negative 1 to isolate the variable x. So x equals negative 7. Now you can check if you want. Plug a negative 7 here and then negative 7 here and simplify and see if it makes both sides equal. To save you the time, that is true. Example 3, we have the surface area of this box right here is equal to this here. The formula of the surface area for a box is this right here. Area equals 2LW plus 2WH and plus 2LH. The question here says to solve or isolate the variable W. Well, in order to solve this for the variable W, we're going to kind of have to do the same thing as what we did before, right? We want everything that has a W to be on the same side. And then this doesn't have a W, so we're going to move that over. So here's what we have. I'm going to put those two together since they both have a W. And then I'm going to subtract 2LH on both ends. All right, if I subtract 2LH, this is going to cancel. And then over here, you would have a negative 2LH. Now, what they have in common is W. So I'm going to pull out the W, and then I'll be left with this. If I took this out and this out, you have 2L plus 2H. And of course, the whole thing is being multiplied by W in this case. How do I solve for W? Well, because what we have here is W times this, inverse of multiplication is division. So that means we're going to have to divide both sides by 2L plus 2H. So basically by what we have inside the parentheses, and that will give you W equals this. So the solution is W equals all this right here. Example 4, we have the following problem. Now, one thing I want you to notice here is that a minus here means it's a negative 1 here. A lot of students tend to get this type of problems wrong. So how do we solve this problem? Well, first thing we're going to do is we're going to distribute this negative symbol here into what's inside the parentheses. And what this does to what's inside the parentheses is basically change the sign, because you're doing negative 1 times 3x is negative 3x, and negative 1 times 2 is a negative 2. So you get this right here. And then we're going to combine the like terms. Well, we have 8x minus 3x. You're going to be left with 5x. Now we're going to move the variables to the same side, and then the constant numbers over to the other opposite side. So we can subtract 3x on both ends. 5x minus 3x is 2x. And then we can add the 2 over to the other side. So plus 2 and plus 2 gets you 2x equals negative 8. And then to solve for x, or to isolate the variable x, divide both sides by 2. You get x equals negative 4. And that is the final solution. Example 5 is tricky, right? We have a variable in the denominator. Whenever you have a variable in the denominator, you have to be careful, right? In this case, x cannot be equal to positive 2, because if x equals 2, 2 minus 2 is 0, and division by 0 is not allowed. It's going to be an error if you were to use a calculator. So how do we solve this problem? Well, the way to solve this problem is similar to that fraction that we did, right? we're going to get rid of this fraction portion right here. I want to get rid of this x minus 2. So let's multiply everything by the LCD. In this case is x minus 2. So if you multiply everything by x minus 2, this x minus 2 and this x minus 2 are going to cancel out. And the same thing over here. And then over here, we have to distribute the 3. So you'll be left with this right here. Now, if I distribute the 3, right, I get 3x and then negative 6 equals 2. Well, x plus 3x makes a 4x minus 6 is equal to 2. Add 6 to both sides, you get 4x equals 8. Divide both sides by 4 to isolate the variable x, so x equals positive 2. But then initially we say that x cannot be 2 because if x equals 2, denominator becomes 0 and division by a 0 is not allowed. So that means in this case, x cannot be 2. That tells us that the equation has no solution. That is, there is no x value that would satisfy this equation or that would make this a true statement. And then we'll look at some word problems after this next example. For example 6, if you have a fraction equals another fraction, just like what we have, the best way to solve this would be to cross multiply. So we're going to multiply the diagonal portion here and then set it equal to the multiple of those two. The next step would be to FOIL. And FOIL stands first times first, the outsides, the inside, and the last. And here's how it follows. First times first means the first of the first factor, and then the first of this. So 10w times 4w gives you 40w squared. And then the outside would be the 10w and then negative 3. Inside, negative 7 times 4w is negative 28w. And then the last would be negative 7 times negative 3. What is that equal to? Well, we can do the same thing on this side. 8w times 5w, that would be 40w squared. And then the outside, insides, 5 times 5w. And then the last terms would be 5 times 7, which is 35. Next step would be to subtract that 40w. Since they both have that 40w, if we subtract that, that's going to disappear. They cancel out. So what we're left with is we can combine those two, right? That gives me a negative 58w plus 21 equals, if I add those two, I get 81w plus 35. From here, we just need to move the variables to the same side and the constant numbers over to the opposite side. Well, we can subtract 81w on both ends. Because it's addition here, I have to subtract. And if we do that, we get to move this 21 by subtracting 21 on both ends as well. Let's add them vertically down. This cancels, and this cancels as well. If I combine those two, a negative plus a negative becomes more negative, equals, if I combine those two, 35 minus 21 is 14. Divide both sides by negative 139 to get w equals negative 14 over 139. Check your solution, make sure this works. Together on a job. John by himself can paint 4 rooms in 10 hours. If he hires Lisa to help, they can do the same job together in 6 hours. If he lets Lisa work alone, how long will it take her to paint the 4 rooms? Okay, what we know is that it takes John 10 hours to complete the job. So that means John can get 1/10 of the job done every hour. As for Lisa, we don't know how long it takes her to complete the job alone. So we're going to let L be equal to the number of hours it would take Lisa to complete the job on her own. From that, we know that Lisa can get 1/L of the job done every hour. We also know that if they were to work together, they can complete the job in 6 hours, meaning that they can get 1/6 of the job done every hour. So the equation that we get out of this is that 1/10 plus 1/L equals 1/6. And to solve this equation, what we're going to do is we're going to multiply both sides by the LCD, and the LCD in this case is 30L, right? Because 10 goes into 30, 6 goes into 30, and then of course we have the variable L. So let's multiply everything by 30L. And basically what this means is that 30L times 1 will give you 30L over 10. 30L times 1, that's 30L over L. And then this times this divided by 6. And then let's simplify this. Well, 30 divided by 10 is 3, so you get 3L for this. And then over here, the L's canceled, so you're left with 30 equals 30 divided by 6 is 5, so you get 5L. Now, the goal here is to get the variables on one side, so let's subtract 3L on both ends. This 3L is going to cancel out, so you have 30 equals 2L. And then to get L by itself, just divide both sides by 2. You get L equals 15. What does that mean? Well, we know that L represents the number of hours it would take Lisa to complete the job if she was to work on her own. So we know that it would take 15 hours for Lisa to complete the job alone. Computing hourly wage. Kim is paid time and a half for hours worked in excess of 40 hours and had gross weekly wage of $910 for 48 hours worked. What is her regular hourly rate? So for the 48 hours that she worked, she got paid $910. The first 40 hours, she got paid the regular rate. For those extra 8 hours, she got paid time and a half, which means 1.5 times the regular rate. So step 1, we're looking for the hourly wage, like how much is she making per hour. Step 2, since we don't know the regular pay, we're going to let X represent the regular hourly wage. Then, since she gets paid time and a half for those extra hours over 40, we're going to represent that by 1.5 times the regular hours, which is 1.5x. So step 3 is to make a table. We have the regular, the first 40 hours, and then overtime would be those extra 8 hours. How much does she get paid for the first 40 hours? Well, she gets paid the regular pay, which is X. For the 8 hours, she gets paid time and a half, which means 1.5 times the regular pay. How much is the salary out of those 40 hours? Well, it's 40 times the regular pay, which means 40 times X, which equals 40X. How much is she making for those extra 8 hours? Well, it's 8 times the 1.5x. Well, 8 times 1.5x is equal to 12x. Now, the salary would be, the total salary we know is $910. So that means the salary that's coming out of the regular pay plus the salary that's coming from the overtime should equal to 910. So that means 40x plus the 12x should equal to the total pay. Well, 40x plus 12x, that's 52x equals 910 hours. divide both sides by 52, you get x equals 17.5. Well, what is x? Well, x is how much she makes during those regular hours, right? So the regular pay is basically 17.5. So Kim regular hourly wage in this case is $17.50 per hour. Now we can double check, right? For the first 40 hours, she gets paid 17.50 an hour. 17.50 times 40, she's making 700 out of the $910. For the 8 hours, she's making 8 times that 1.5 times the regular pay, which happens to be 210. If you sum this number with this number, you should get the total amount, which works in this case. Chemistry mixing acids. A laboratory has 60 cubic centimeter of a solution that is 40% HCl acid. How many cubic centimeters of a 15% solution of HCl acid should be mixed with a 60 centimeter cube of 40% acid to obtain a final solution that is 25% HCl? How much of the 25% solution is there? So we know we have 60 cubic centimeters of this 40% solution, but we don't know how much of this 15% solution we have. Here's a table. So we're going to let X be the amount of that 15% solution of HCl acid. Here's a table. We're mixing this 15% solution with the 40% solution to obtain this final solution, right? How much of the 15% we have? Well, we don't know. So X represents that. But we know that there is 60 cubic centimeters of this 40% solution. If I mix those two up, the final solution should be X plus 60. Here's a picture. So we have this 15% solution is being mixed with the 40% solution to obtain a final solution that is 25%. How much of the 15% we have? Well, we don't know, so we're going to let that be X. We know how much of the 40% solution we have. That's 60. And the final should be, because we're mixing those two, it should be the sum of those two. So X plus 60. Now, what we're going to do is basically we're going to multiply those two, and sum them up. And that should be equal to this times this. And that's what it looks like, right? 15% is the same thing as 0.15. That's where that 0.15 is coming from. And then the same thing, 40%, and then 25%. And from here, we basically just solve for X, and we have our answer. So we're going to multiply this 0.40 with 60, and then distribute this over to get this equation here. And we don't have like terms that we can combine here. We don't have like terms that we can combine here. So the next step would be to move the variables to the same side. So we're going to subtract that 0.15x and 0.15x. This cancels, so we have 24 equals 0.10x plus 15. Take this 15 over to the other side by subtracting. And what we get is 9 equals 0.10x. Well, to isolate the variable x, we can divide both sides by 0.10. And that will give you x equals 90. What does that tell me? Well, since x is the amount of that 15% solution that we have, that means we have 90 cubic centimeter of this 15% solution, right? And then, of course, we have 60 cubic centimeter of that 40% solution. But if I mix those two up, 90 plus 60 should be the final result here, which is 150 cubic centimeter of that 25% solution is what we have. So from here, what we know is that 90 cubic centimeter of 15% solution of HCl should be mixed with the 60 cubic centimeter of that 40% acid to obtain a final solution of 150 cubic centimeter of that 25% solution. All right, let's look at this example here. We have two cyclists that are 90 miles apart, and they start riding toward each other at the same time. One of the cyclists is going twice as fast as the other. If they meet 2 hours later, at what average speed is each cyclist traveling? So here's a rough sketch of what's happening. What we know from here is that the two cyclists are 90 miles apart. The distance between them is 90 miles. One of the cyclists is going twice as fast. So that means, let's suppose the cyclist on the left-hand side is going at the rate of r. The second cyclist is traveling at twice as fast, so that would be 2r. So those two cyclists are meeting after 2 hours. So to solve this problem, we're going to use the distance formula, where the distance is equal to the rate times time. So to start the problem, we're going to let r be equal to the rate of cyclist A, and then 2r would be the rate of the cyclist B. So making a table, we have the following. The rate of the cyclist A is r. The time, well, we know they meet after 2 hours, so for each one of those two, it's going to be 2. The distance is the rate times time. So the rate of the first cyclist is r, and the time is 2. So if you multiply those two, you get the distance. You can do the same thing for the cyclist B. The rate of the cyclist B is 2r because he's traveling twice as fast, and the time it takes for them to meet is 2 hours. So the distance of cyclist B would be 2 times 2r. So what we know is that the distance covered by cyclist A plus the distance covered by the cyclist B is going to be equal to 90. So distance equals rate times time. So we have the distance of cyclist A, which is 2r, plus the distance of cyclist B, which is 2 times 2r, should be equal to the total distance, which is 90. And that's basically what we have. Now, we're going to solve this equation for r. So first thing is first, we're going to multiply this. So that will give you a 4r. 2r plus 4r is going to be equal to 6r. So we get 6r equals 90. And to solve for r, we're going to divide both sides by 6. And the reason that we're dividing by 6 is because we're multiplying here. To undo that, we have to do the inverse of multiplication, which is division. So divide both sides by 6, you get r equals 15. Well, what is r? Well, initially we say that r represents the rate of cyclist A. So that means cyclist A is traveling at 15 miles per hour, and cyclist B is traveling at twice as fast. So that would be 2 times 15, which is 30 miles an hour. Let's talk about linear inequalities. A linear inequality is a relation that describes a range of possible values for the variables that satisfy the given inequality condition. So we have the general form for linear inequalities are as following. We have 4 of those. First one deals with less than symbol, less than or equal to, greater than, or greater than or equal to. So it's going to have one of those symbols, right? Where a and b are just constant numbers. X is the variable that we're going to solve for. And then c is a constant that the expression is being compared to. Remember, we're comparing the left side to the right side. So how do we solve linear inequalities? Well, the way to solve a linear inequality is very similar to a linear equation. The only difference here is that when you divide or multiply by a negative number, the inequality symbol is going to switch. It's going to reverse the other way. So it goes from less than to greater than, and vice versa, and so on. So let's look at the steps of solving linear inequalities. The first step is that you have to distribute any numbers that are outside the parentheses, right? That should be the number one goal that we have to do. Step 2, combine like terms on each side of the inequality. So if you do have like terms, make sure you combine those two before you proceed to the next step. Step 3, isolate the variable. And of course, in order to isolate the variable, we have to perform the inverse operation, right? And then step 4, that's the one that's kind of tricky. A lot of students do make a mistake on this part. Check if you need to reverse the inequality sign. When do you reverse the inequality sign? When you multiply or divide by a negative number. And step 5, express the solution either as an inequality, interval notation, or on a number line. We're going to look at those 3 different ways of writing the solution. Let's look at the first example here. If I want to solve this linear inequality here, the process of solving this inequality is the same as equations, right? Always get rid of the constant numbers first. Move the constants over to one side, and then the variables stay on the one side. So first thing I would do here is I would subtract 3, inverse operation, and then you get 2x is less than 4. And since 2 is being multiplied to x, to get x alone, I have to divide by 2 on both ends. Division is inverse of multiplication. And then you get x is less than 2. So the x values that would satisfy this inequality are all x values that are less than 2, right? Every x value to the left of 2 should make this a true statement. Thus, the solution is x is less than 2, which means all values of x that are less than 2. In a number line, since 2 is not part of the solution, it does not start at 2. It starts at numbers that are less than 2. So that means we're going to have an open circle. So whenever you have the less than or greater than symbol, it should be an open circle right above that number. And then you shade everything to the left of that 2. Meaning everything that's shaded in this case is a solution to this problem. In interval notation, this is the graphical solution. In interval notation, that's basically using the brackets and parentheses. When do we use brackets and parentheses? Well, use brackets when you have one of those symbols, less than or equal to or greater than or equal to, meaning the solution starts at whatever that number is. Over here, if it's less than or greater than symbol, we have to use parentheses, meaning the beginning number and the numbers are not part of the solution in this case. So for this case, since less than symbol falls here, we have to use parentheses. So the smallest possible number here, which is negative infinity, all the way to the number 2. So a solution in interval notation would be from negative infinity all the way to 2. Remember, you're getting smaller and smaller and smaller, so the smallest possible number that we use is negative infinity. And then, of course, it starts around 2, not including 2. Example 2, what if I have this problem here? Well, I don't have anything to distribute in this case. Step 2 says to combine the like terms. Well, I don't have any like terms on this end or this end. Step 3, that's where you move the variables around and then you isolate the variable x. So let's go ahead and take away the 3x over to the other side. Since I'm moving that whole 3x, I have to subtract it over. Now you get a negative 8x plus 8 is less than or equal to 16. Now notice here, when you subtract, you do not flip the symbol. Symbol stays the same. And then we're going to take away the 8 by subtracting. So you get negative 8x is less than or equal to 8. Now, the next part would be, since we're multiplying here, inverse of multiplication is division. Let's divide by -8. And notice here, we're dividing by a -8, so we have to reverse the inequality sign since we're dividing by a negative number. So the -8's cancel, you're left with an x, and then that symbol flips over, you get -1 on the other side. So the solution to this problem is all x values that are greater than or equal to -1. So a -1 in this case is part of the solution. In interval notation, since I have that equal to, or the line underneath, and the solution starts at -1, I'm going to have a solid point at -1, meaning that -1 is part of the solution, and everything to the right gets shaded. That is the graphical solution. In interval notation, remember, it says to use brackets when you have the less than or equal to or greater than or equal to, and that's what I have. So that means the starting point right here is going to have a bracket around -1, but infinity and negative infinity is always going to be parentheses because you can never reach these numbers. It just gets smaller and smaller and smaller and smaller forever. Doesn't stop. So around infinity and negative infinity, it doesn't matter what symbol you have, it should always be a parentheses. Those numbers should be a bracket or parentheses depending on the symbol. So in this case, any number to the right of -1, including -1, is a solution to this inequality. Example 3, we have a fraction involved. So first thing we're going to do here is we're going to add the 4. Let's get rid of the 4 since it doesn't have a variable by adding 4 on both ends. We get 2x divided by 3 is greater than 6. Now I don't like to deal with fractions, so we're going to multiply by 3. Now the 3's here are going to cancel out. Or you can think of it as 3 times 2 and then divide by 3. So you get 2x is greater than 18. To isolate the variable x, divide both sides by 2, and then x is bigger than 9. So the solution here is that all x values that are bigger than 9 should satisfy this condition right here. The graphical solution, you're going to have an open circle at 9, and then you shade everything to the right of that. Interval notation, well, since we're dealing with greater than 9, 9 is not part of the solution, so it's going to be an open parentheses around 9, and then you go all the way to infinity. And again, parentheses around infinity as well. Now, problem 4, a little bit challenging than the previous ones, is we're going to distribute the 5 first to get 10x minus 5 minus 3x is greater than 4x plus 7. That's step 1. Step 2 says to combine any like terms. Well, I have a 10x and a minus 3x. That makes a 7x. So a minus 5 is greater than that. And then we're going to move the variables around. So step 3 says to move the variables to the same side and isolate the variable x. So let's go ahead and take away the 4x over to the left by subtracting. 3x minus 5 is greater than 7. Move the constant over to the other side by adding. So plus 5, you get 3x is greater than 12. Well, to get x alone, divide by 3, you get x is bigger than 4. So again, the x values that would satisfy this would be all x values greater than 4. Number solution, the graphical solution of this would be an open circle at 4, and everything to the right would be shaded. So that's the graphical solution. Interval notation, since I have an open circle here, it's going to be a parentheses on this end, parentheses on this end. So from 4 all the way to infinity with a parentheses on both ends. And again, parentheses means that 4 is not part of the solution. Remember, all x values that are bigger than 4 are the solution. And then we have what we call a compound inequality. Compound inequality involves two inequalities that are combined by one of the statements here. It's and or. So let's look at the and first. When two inequalities are joined by and, the solution portion of that inequality would be the intersection area, or the area where they overlap. Solution must satisfy both inequalities in this case. Whereas the solution is the union of the individual solutions. That is, the solution must satisfy at least one of the inequalities. It does not need to satisfy both in this case. So as long as it satisfies one of the inequalities, that will be accepted. Here is an example that we can look at. So let's say we want to solve this inequalities, right? They are connected by the word and. So let's solve it one by one. So if I look at the left-hand side, I can subtract 2 on both ends, and to get x is less than or equal to positive 2. And if I look on the right side, we can subtract 2, x is greater than negative 1. So one says greater than negative 1, the other one says less than or equal to 2. Well, for the word and, the solution should be the intersection area, right? It's the area where they intersect or overlap. So let's go ahead and graph those. I have a dark solid point around 2 because 2 is part of the solution. According to this, x could be 2 or less than 2. And then since x is bigger than negative 1 is not part of the solution, so it's going to be an open circle around the negative 1. Now this one says x is to the left of 2. So one is going to be shaded this, the other one is going to be shaded to the right. Right? Bigger than negative 1, you're to the right. Less than 2, you're to the left. The area they have in common would be this area right here. That's where they overlap. So that means that middle portion would be their solution. So the graphical solution would look like this. Now, the solution in terms of inequality would be this right here, where this x variable would be in the middle. It's going to be less than or equal to 2 and greater than or equal to negative 1. So the solution would be every x value between those two numbers, including 2. In interval notation, it's an open circle, open parentheses around negative 1, and then a bracket around 2. Meaning 2 is part of the solution, whereas negative 1 is not part of the solution. And every number between those should be a solution in this case. For example 6, we have the word or. So let's go through the process. Let's add 3, x is less than 5, and then let's subtract 4, x is bigger than 2. So since it's an or, it just needs to work on one of those inequalities, right? It needs to satisfy at least one of the inequalities in this case. So let's graph the solution set. So we have an open circle right above 5 and 2, since they're not included. And then we're going to go to the right of 2, bigger than 2, and then to the left of 5, since it's less than 5, and then to the right of that. Now, the solution, it just needs to satisfy one of those inequality symbol. And as I can see here, you start from here, you continue all the way to here, and then it continues from here. So this, in this case, the solution to this would be everything, every x value. It doesn't matter what x value you pick, it should satisfy this or this, at least one of those. So since everything is shaded in this case, it would be from negative infinity all the way to infinity. Another word for that is all real numbers should satisfy this condition right here. Example 7, we have a compound inequality. In this case, the variable x is in the middle. So when you're solving for x, it needs to stay in the middle. You cannot move this term over to the left or to the right. So First thing is first, let's move the constant -1 on all the sides by adding 1. -2 plus 1, that's -1, less than or equal to 3x, less than 6. To isolate the variable x, divide everything by 3. You get -1/3 is less than or equal to x, and it's less than 2. So my solution in this case would be everything that's less than 2 and bigger than or equal to -1/3. So it's basically the intersection area. So x, or the solution, must be between those two numbers, including that number. Right? Since -1/3 is included, it's going to be a bracket around that. And then you don't have the equal symbol here, so it's going to be parentheses around the 2. Example 8, we have a fraction involved in this case. So I don't like dealing with fractions. Let's go ahead and multiply everything by 3. On the left side, I get a 3. On the right side, I get a 12. Over here, the 3 is going to cancel out. So 3 times this and dividing by 3, you're kind of undoing that whole thing. So you get 2x plus 5 in the middle. And then very similar to that previous example, subtract 5 on all the sides. You get -2 is less than 2x, less than or equal to 7. And then divide everything by 2. -2 divided by 2 is -1, and this would be 3.5. Middle will be just an x. Now if you notice on both ends, right here, this has the line underneath. That means it's going to be a bracket on both ends. X is less than or equal to 3.5, meaning 3.5 is part of the solution. And of course, -1 is part of the solution as well. So with the bracket, -1 to 3.5 would be your solution right here. And then our last example here, example 9, is what if I have this? Well, the process would be the same. Let's get rid of the fraction first. And to get rid of the fraction, you have to multiply everything by the LCD. LCD of 3 and 2 is 6. That is, both those numbers go into 6. So we're going to multiply everything by 6. Instead of distributing that 6 over here, I'm going to simplify it right here first. I can divide it first, and then the leftover could be multiplied to this. So 6 divided by 3 is 2, so you get a 2 for that, and then bring down the 2x plus 1, the symbol less than, and then I can do the same here. 6 divided by 2 is 3, and then multiply it to the x minus 5. And now we can distribute the 2 and 3. If I distribute the 2, I get a 4x plus 2, and then on the other end, I get 3x minus 15. Let's move the variables to the same side and then the constants over to the other side. So we're going to subtract 3x first. X plus 2 is less than or equal to -15. Let's move that 2 over to the right by subtracting 2. X is less than or equal to -17. So -17 is part of the solution, and everything to the left of that should be a solution as well. So in interval notation, this would be from -infinity, because you're going to the left, all the way to this number, -17, with the bracket around -17. And again, bracket, because you do have the less than or equal to symbol here. Excuse me. And then we have special cases. We have no solution. Well, an inequality like x plus 5 less than x minus 3 results a false statement. So when you solve the inequality symbol and then you end up with a false statement, then the inequality has no solution. And what do we mean by that? Well, if we try to solve this for x here, I would move the variables to the same side. So in this case, I would subtract x on both ends. And then you get 5 is less than -3. Well, 5 is not, a positive number is not less than a negative number. So that's false, and therefore it has no solution. That is, you cannot come up with an x value that would satisfy this condition. And then we have what we call all real numbers as a solution? Well, if we try to solve this, you're going to come up with a true statement. So let's bring it down here, move the axis to the same side by subtracting. We get 4 is greater than or equal to 2. Well, that is true, right? 4 is bigger than 2. It does not need to be equal in this case. As long as it satisfies one of those conditions, either 4 is equal to that or 4 is bigger than that number, that is going to be always true. And therefore, since this is true, it has all real numbers as a solution, meaning from negative infinity all the way to infinity would be a solution. You can put in any x value that you want here. It should satisfy this condition. It should make it a true statement. So a conclusion, linear inequalities represent range of values that a variable can take, right? With equations, you could have 1, 2, or 3 solutions. Inequalities, you have solutions between multiple numbers, right? You could have solutions, for example, solutions between 1 and 2. There could be millions numbers, right? How many numbers are between 1 and 2 if you think about it? There's tons of numbers, right? 1.1, 1.01, 1.5, and so on. There's so many numbers that you could have when it comes to linear inequalities. To solve a linear inequality, you follow the same steps as a linear equation, but one thing you have to keep in mind is when you multiply or divide by a negative number, the inequality symbol flips over, right? Don't forget to reverse that. And then compound inequalities are inequalities that are combined using the words and or, and their solution is the intersection or the union, depending on which one you're working with. And is the intersection or the area they have in common, where they overlap, and or is basically everything together.